Okay, hey YouTube. This is Brian, and it's been many months since I've worked on a project related to audio. Been preoccupied with many other things. Bought a motorcycle. Been working on that, and a lot of work around the house and a lot of yard work. So, gosh, it's probably been a year, maybe, since since I've done anything in the electronics lab here. So had a spare moment and thought I'd get my workbench back in shape and fish around in my parts pile and see if there's something interesting to do. And I found something. About a year ago or so, I purchased a whole bunch of tube amplifiers on eBay, and I don't know, I must have gotten 5 or 6 of them, just for basically for parts and just to tinker with. And sometimes you need an old carbon resistor or maybe a transformer or some tubes. So I just I found this lot of 6 amplifiers, and most of them were from organs. And I have this parts pile sitting around, and I realized I had 2 of these, and I'm not sure what they are, or who the manufacturer is. But there are 2 identical amplifiers that look just like this. They have a volume knob, which doesn't really have an on and off switch, and then there's a tone control, which has an on off. So to turn it on, and then you adjust the tone, and then here's the volume. So I thought it would be interesting to, well, first of all, see if this thing works, and since I have 2 of them, make a stereo pair out of them, just for the fun of seeing if they work and troubleshooting them. And maybe I'm sure the looks like this electrolytic power supply capacitor has been, somebody at some point added this. Probably these electrolytic capacitors only last about 10 years before they dry up, and somebody has replaced. I think I can see internally there's another one that looks like it's leaking, and I'm gonna take this apart in a minute to look at it. But at some point someone bypassed the internal one and added this one, and this one's old too. This one needs to be replaced. Of course, that's one of the first things. That is the first thing you do to an old amplifier, is replace the electrolytics, because again, they have about a 10-year lifespan. And this organ amplifier is probably something from the 1950s or early to mid 1960s. So it's 5-6 decades old. Therefore, every electrolytic in this thing, and this is a real simple circuit, there shouldn't be that many, but every electrolytic in this should be replaced. So I thought it'd be fun just to go through the exercise of getting this thing running, just starting out to see if it actually works as it is, and then putting on the scope, listening to it, see if there's any buzz or hum, see what's wrong with it, fix it if it's inexpensive enough, and then make a stereo pair out of it. And another thing I'm going to do at the same time I'm working on these is build a couple of speakers. I've got this old one of my test speakers that I use. When I had these old speakers laying around, and I just made a test speaker out of it. Something that if it blew up, it wouldn't matter to me. These are just some old drivers that I had laying around. And anyway, I did blow one of these things. That one there. Listen to that. That one is gone. The rest of them work. But yeah, these are really cheap. And I never liked this thing anyway. I used a cigar box. I have a whole bunch of cigar boxes that I use for storing components in. But anyway, so this is kind of blown. Can't really use this anymore. So I wanted to make kind of a good speaker for my bench, or maybe a pair of speakers for the bench. And so I found this really interesting speaker made by, I don't know pronounce it right, Fatale. It's an Italian full range speaker. And this is actually brand new. On paper it looked really interesting. You know, it looked almost, you know, the frequency response and the characteristics of this thing look really, really good. And I love full range speakers. There we go. Fresh out of the box. There it is. It's a little 3-inch, I think, 3.5-inch speaker. And it just looks so good. And it's pretty inexpensive too. And so I got on the I bought it from Matasound, which is one of my favorite companies for buying speaker components, and I used the Matasound speaker designer software, and I ran the numbers, and you know I found you know, I entered in the teal small parameters and found the length of the port and the box size I needed and that sort of thing. I won't get into all that. I'm not going to get into how to design a speaker, but I do recommend Matasound's speaker design software. And the frequency response, I ended up getting, I got to look it up again, but something on the order of like 50 hertz. You know, after you put the port in it and you design it right, and 50 hertz up to 20 kilohertz, pretty flat. You know, this it looked really, really good. So I thought this would be good to use as my bench speaker, and I actually want a pair of them. So I'm going to be, at the same time I'm working on this amp, I'm going to be building this too, because I'll show you how I'm going to do it. Well, I'm not quite sure yet, but I am going to use, since I have about 1 billion cigar boxes laying around, I'm going to use a cigar box and build the speaker. I'm going to have to, you know, make some improvement to seal this thing and cut the holes in it and that sort of thing. But I did purchase the terminal lugs, positive and negative, for the back, and I did purchase the port. And when I ran the numbers on the Matasound design, speaker design software, the port diameter came up to be 2.5 centimeters, which is about 1 inch. Is that right? 2.54. Oh, I don't know. Yep. So I got a 1-inch port, nice flared port. Got that from Matasound as well. And the length of the port needs to be 4.94 centimeters, so I have, you know, plenty of the length on this port so I can cut it. So 4.94 is, you know, roughly there. And I'm gonna, here's the front of the cigar box. So I'm gonna, you know, cut a hole and roughly center the speaker, and then put the port somewhere down there like that. So I'm going to have fun making these speakers, these little full-range speakers, and probably pair it up with the stereo amp that I'm hopefully about to build with these old tube amplifiers from an organ, if I can possibly get them to work without, you know, without spending a mint on them. So that is the project. Kind of two projects going to happen at the same time, and I'm going to film them both. So the first thing I want to do is start with this amp and just see if it works. Period. Before I do that, I want to pull these tubes out. I'm just out of curiosity and look the numbers up and see what kind of tubes they are, and then put them in the tube tester to see if they're shorted, or to see if they're functional. Because I really don't want to buy tubes for this thing unless they're really cheap on eBay. I'm hoping these vacuum tubes actually still work. So I'm going to pull these off, look them up in the tube manual, see if I can test them on my my Heathkit tube tester, and see if they're still working. Put them back in, and then slowly bring this up on a Variac, and put a load on it, bring it up, and put a signal in it and see if we get anything out of it. I would expect it would, if I get something out of it, if the capacitors don't blow up on me. I would expect it to be kind of noisy, because I fully expect this capacitor to be dried up. I think I'll open it first too, just to see if there's anything going on inside, if anyone's tampered with it. I think someone actually added this, so to see if there's any loose ends in there, or anything cut, anything I need to know about before I put it on the Variac. So that's the first step. Pull the tubes off. I'm going to open this up, look at it, put it back together, test the tubes, then bring it up on the Variac, and well, let's see what happens. That's really what I enjoy about this hobby. Oh, that's not a missing tube. That's by the way, this right here, this is not a tube socket. This is probably a receiver for the other circuitry that connected to this. This being from an organ. Some kind of cord went to. There's actually, that's an input right there, RCA type for signal, but something may have controlled this somehow. Not quite sure. Not too familiar with the design of those old organs, but definitely not a tube socket. So it looks like we have everything here. So okay, enough talking. Let's take these tubes out, take this apart, look inside, and see what's going on. First, let me get my speaker stuff out of the way. Okay, let me hit pause here, and then we'll take it apart. Okay, got my socket set out. First thing I want to do, there's a couple of machine screws I think that have to come off so we can open this up, but I'm going to go ahead and pull the tubes off. Normally I would I wouldn't touch the tubes directly. I'd put a sock on my hand or wear a glove, but these are so old and they're sticky. And I'm not trying to restore this thing. This is an RCA tube, a 12AT6. Okay, made in the USA. This tube, well, these look really burnt up inside, but that just happens, that burnt stuff just happens during the manufacturing process when they light up the little, what do they call that thing, the getter in there to burn off any ions or any remaining impurities in there. This is Sylvania. And I don't see, oh, there it is. Boy, that's tough. What kind of tube is this? Hang on a second. A 50C5. 50C5. So these tubes are going to be, it's probably going to be the same as this one. No. Put these in order. I pull them off. And this one is also Sylvania, a 35W4. So let's look these tubes up and see what they are. Okay. And these are labeled. These are the tube types are stamped into the. Hang on a second. They're stamped into the brass or copper. This is copper, I guess. Yeah, 12AT6, 50C5, 35W4. Looks to be a little corrosion on the transformer. There's definitely corrosion on the transformer. Okay. So we have the tubes out. Let's go ahead and take this apart. And I'm not gonna really pause. When I make these videos, I don't really produce them. So I don't have time for that. I just kind of make them as I go and put up what I have without doing any real production values, because that's the boring part to me. The fun part is playing with the amps and fiddling around with video editing software. It just drives me crazy. Plus, the way I make these videos is I really don't have a script. I do things as I go. It's kind of like, whoever's watching this is kind of like, sitting here with me at the workbench and helping out. So, it could be after I take this apart, the whole thing's a piece of junk, and I'm going to scrap the whole idea, and you're wasting your time watching the video. But that's, that would be the same thing as if you were here with me. Okay, look at that. Hope the camera. Adjust this light. All right. So someone's definitely been in here. They used electrical tape. Looks like to splice together wires to add this capacitor to presumably replace this old electrolytic, which is definitely leaking. That thing is in bad shape. So we're going to have to remove that electrolytic, remove that one, and find a replacement for it. And I see that on the tone control knob there's some, might be hard to see, but there is some corrosion, maybe from the capacitor somehow, I'm not sure. And we get a pointer. Okay. Hoping this comes across a little bit on the camera, but let's see. Okay. This is the potentiometer right here, and that's, I don't know if you can see that, but there's just corrosion flaking off the housing of the potentiometer, so we're going to probably end up having to spray that out as well. But let me take a look. I've got some of that. There we go. This is what I use, Deoxit. I think everyone uses this just about. Deoxit F5 cleans and lubricates, improves contacts, protects surfaces. I just spray the crap out of everything with this and wipe it up, and it does a great job. Don't need to use that yet, but just checking to see that I had some on hand. Alright, is there anything else in here that's burnt up or... Ooh, there's a big old carbon resistor in there. That's pretty cool. I'll show you that later. So these splices here, I don't know what's... I guess there's solder below there, but whoever did this used... didn't use any form of shrink wrap. They used electrical tape. I'm just making sure there's no short circuits or anything. I'm going to leave this I'm going to leave this hooked up like this while I test it initially to see if it works. I'm hoping whoever bypassed this capacitor, tested it and used it, and it probably did work. I don't see anything else that's burnt up in there. Weak. Alright, so it looks pretty good. I'm just going to leave it apart. Now, one of the things I like to do is when I take these parts, when I take parts off, I like to store them somewhere, like on a magnet, or in a little. In this case, I'm going to find a little tray. Go ahead and use this little tray here. Okay. Alright, so let's. The next thing I want to do is look up these tubes and see, just out of curiosity, see what they are, what the tube manual says they are. I know what the 12AT is. That's just a standard preamp type tube, and of course one of these other tubes has to be. These other two are going to be power. Power tubes, probably pentodes. Okay, let me get my tube manual out. I'm familiar with the main, the tubes that we all, 12AX7, AT7, all the standard, 300B and triode and all the standard power tubes you see in all the the modern amps. But some of these, there's just a ton of these old tubes they used back in the day, and I'm not familiar with all of them. Like the 35W4, it's going to be a rectifier, and this 50C5 is going to be a power pentode, I think. The 50 is the power supply voltage. I'm sorry, the heater voltage. Like the 12AT6, it's 12 volts you apply to the heater. The 50 C5 50 is going to be 50 volts for the heater, which means that's what you get with a half-wave rectified 120 volt. So, interestingly, that explains it. there's no power transformer here. This power cord comes right in, and it's probably going to go right to the rectifier, and it's probably a half-wave rectifier, not a full wave. And the reason I say that is because the main amplifying power tube is a 50C5, meaning that the heater voltage is 50 volts, and that's pretty much what you're going to get out of a half-wave rectified smooth power supply signal. Line voltage, just thinking out loud. So 35W4 is going to be a rectifier. Let's look these things up. I'm just talking out loud here. Okay, I have my RCA receiving tube manual, and we have the 35W4, which indeed is a half-wave vacuum rectifier, miniature type used in power supplies of AC/DC receivers. Requires miniature 7 contact socket. This type is equivalent in performance to the glass octal type 35Z5GT. The heater is provided with a tap for operation of a panel lamp, and we do have a panel lamp on this thing, right there. And so, yep, well, it's just basically a diode. Okay. Alright, so we know that that's going to be the rectifier. Not that we need to know that, I'm just curious. Let's look up the 50C5. beam powered tube. That's going to be a pentode. Miniature type used in output stage of compact AC/DC radio receivers. Requires miniature 7 contact socket. Adequately ventilated. Okay. See the heater voltage AC/DC. There's the 17 C5, 25 C5, and 50 C5, and there you go. The 17 C5 needs 16.8 volts for the heater. The 25 C5, 25 volts, and the 50 C5, 50 volts. And in typical operation, we have a total harmonic distortion of 10%, and the maximum signal power output is 2.3 watts. So this is very low. This would have been really good for the organ, that it was in. But I'm just curious to see how this sounds with hooked up to an audio circuit. The 50 volt heater is designed to operate under the normal conditions of line voltage variation without materially affecting the performance or serviceability of the 50 C5. Series heater. As a power amplifier class A1, the 50 C5 is recommended for use either singly or in push-pull combination in the power output of the Okay. And of course the 12 AT6 is a standard, well-known preamplifier, voltage amplifier, pentode. Hang on a second. I can't find it. Okay, I was looking up this tube, the 12 AT6. It's a pretty common tube. I've seen it around, but I couldn't find it. When you go through one of these old, receiving tube manuals, and you're in the 12 volt heater section, where you'll find many of the common tubes. I'm going through here. I can't find the 12 AT6. We go from 12AX, 12AU7. We go from the 11 to the 12AB5, the 12AT7, but not AT6, 12AU6, AU7. Well, a lot of times, you look in the 6 section, the 6 volt section, because the tubes are identical, except for the almost identical, except for the heater voltage. So I go over to the 6 volt section, and we have the 6 AT6. Again, this tube being the 12 AT6, and sure enough, under the 6 AT6 section, in small print is the 12 AT6, because it's gonna, basically it's the same tube. The difference being, the heater voltage, one being 6 volts, the other being 12. And as you can see here, the 6 AT6 requires 6.3 volts on the heater, 12 AT6 12.6 volts, and the heater currents differ, and the peak heater to cathode voltage rating, which is a very important rating to prevent arcing internal to the tube, is identical between the two tubes. And then the remainder of the specifications for the tube is are identical to each other. And as we can see here, this is I was wrong when I said it was a pentode. It turns out it's a high mu triode, miniature type, used as a combined detector amplifier. Automobile, AC operated radio receivers. So, here's the tube schematic, and it's got a couple of taps on it. So here's the cathode, the grid, the control grid, and the plate, and it's got these neat little taps right here. I don't know if it's coming across, but number 6 and number 5 are basically little diodes. So you can tap off these from these diodes and get a halfway rectified signal. Oh, let me see here. Maximum rating. So this is gonna be used. It's interesting. They don't give me, they don't give me. I was hoping to, just out of curiosity, I was hoping to get the anode characteristic curves on this. I was just curious, but this manual's not giving. Let me go pull this on the computer real quick. I'm just curious. Okay. So I don't know why I'm digging. There's no, this is just pointless. I don't even need to be doing this, but I'm always, curious about these things. Duplex diode triode, just like we talked about before. We have it's a triode. I think I said dual triode. It's not a dual triode. It's a dual diode plus one triode. So there's our cathode, there's our heater, there's our cathode, our grid, and our anode. And then again, 5 and 6. I'm showing it again because this is a better diagram. It's a little bigger. And then here are the anodes for our diodes, so you can get a half-wave rectified signal off those. Okay. And high mu triode designed for use as a combined detector amplifier and automatic volume control tube, except for heater ratings. 12 AT6 is identical to the 6 AT6, and there's our plate resistance and transconductance 13. And there's the curves. There's the plate characteristics. It looks pretty, it's pretty linear. I mean, that's what you look at these curves right here for a tube triode, and damn, this is just super linear. I mean, you could design an amplifier operating in this range right here, and without negative feedback, and have a damn good amplifier. You just don't see curves like this in the transistor world. That's why transistors require so much crappy negative feedback just to compensate for their inadequacies. Okay, so anyway, so now we know. I went through this whole exercise for really nothing, but now we know we have what's going on here. Is we have the power supply consists of a 35W4 half-wave rectifier, so it's a half-wave rectified power supply. We go into a single triode that provides the voltage amplification, and we go into a pentode that will provide the current amplification, maybe a little bit of voltage amplification as well. And then the load for this will be the output transformer, which will be coupled to presumably an 8 ohm speaker. hopefully. And so it's, you know, there's no power supply transformer here. So this is about as simple as it gets. I like simple. I'm hoping to get it working. So first things first, let's go ahead and test these tubes. You know, one way to do it is to hook everything up, put it on the variac, bring up the voltage, and look for fireworks. You know. But I'd prefer to go ahead and test the tubes first, because if one of the tubes is internally shorted or bad, then it's just, I don't even want to run the risk of blowing anything up inside of the circuit that I don't have to. So let's go ahead and get the tube tester out. And here's my workbench. It's all mostly used and used gear and old gear and inexpensive stuff. Nothing high end. Nothing fancy here. I don't like expensive, high end, and fancy stuff. I like making do with the old manual things, and things that are used and old but still work. Okay. I'm going to plug this. I'm going to plug my tube tester into the variac. Okay. Power's off. And let's start out with the 12. Let's see, 12 AT6. I bet this is not going to be on. We'll start with 6s over here, 6 AT6 if I can find that. Yeah, we have a 6 AT6. Good. So the only difference would be the heater voltage, but let me see if I can find the 12. Yeah, we have a 12 AT6. Good. Got it. So start out with the first test. Okay. I always have to get my directions out for this. Okay. Okay, so start out with type, which is 1, filaments 12.6 volts, plate is 35, and the buttons that go to the top are E, and the buttons that go to the bottom, the levers that go to the bottom, are B and C. let's go ahead and insert this. And turn it on, and turn this light off. Before we do any test, we want to make sure that the heater is working, and sure enough, I see a little glow in there. Yep. So that's a good sign. This tube probably hasn't been operated in 5 decades. So it's good that there's a little glow going on in there. The heater is working, and before we run any test here, we want to get the tube warmed up. Just like any tube, the heater's got to warm up the cathode so that it emits all the electrons. Okay. So to check for, I don't use this that often, so I always have to read the directions and make sure I don't do anything stupid. But so reading the directions, check the tube for shorts by moving the lever shown in the light type through 2 positions, returning to the position shown on the chart. The light type. Okay, well, the light type, you can't see this, but the top E, we go through 2 positions and back, and if there's a short, this little light would light up right here. It says short. I know that works. A short is indicated by a steady glow of the neon bulb. Disregard neon bulb flashing as lever switches are moved. Okay, so we did the E, and then the B is also in light type, so we go boop. Nope, no short. Disregard the light that lights up while the lever's moving. It's a steady glow that we're looking for, so no shorts. Okay, check the tube for quality by moving the test slide switch to the test position after allowing sufficient time for the tube to reach operating temperature. So here's quality right here, test. And I don't know if you can see that, but the meter, the needle is in the good range, the green range. Okay. You know what I should have done is I should have done the line test first. You're supposed to do it. You're supposed to get the line voltage right in the middle, right here. That's what I'm thinking out loud. Let me do that first. We want to get that right down there. I'm going to use the Variac to lower the voltage. Okay, there were the meters right on the line test right there, so that's good. Okay. Just see here. All right, now I should have done that. Anyway, so with the line voltage in the middle, and I do test. Now we're indicating bad. You see that? So I've set the line voltage dead smack in the middle where it belongs, where it says line test. And I push the test button, and you can see that the meter goes down to the left. It's right on the line between bad and yellow and questionable. It's right on the line. I don't know if that's coming across or not. Yeah, it is. Okay, so right on the line is good enough for me, because I'm not trying to build a masterpiece here. I'm trying to get these things working again, and you know, yeah, they're not going to be the ultimate in hi-fi. I just want to get them working, so this tube is sufficient. It'll do the job. Okay, test for open elements. Hold the slide, switch to test position, move each lever in the top position to the bottom, and satisfactory tube elements are indicated by a change in the meter reading. So the ones that are on the top go to the bottom. There's only one on the top, and there was a change in the meter reading. So that's good. Okay, to check for filaments, check the filament, which is the heater. Set the filament selector switch to 0.75. Move each lever shown in dark type through each of its other positions. Satisfactory filaments, taps, and internal connections will be shown by a bright glow of the short. So this is going to glow this time if the filament is good. And the only one in dark is C. So, see, it's glowing. So that's a good thing. Alright. Now, that is the, what I've done is, keep in mind, this is interesting that, you're remembering that, this 12AT6 is, we just tested the triode portion, but there are 2 diodes as well. So, you can't see this, but on this chart right here, there are 3 tests that have to be performed for the 12AT6. We just did one of the 3. Let's do the other one. The other 2 right now. The other 2 are going to check the T6. Check the diodes. Okay. What did I just did? I did E and B and C. E, B, and C. Okay. Now, do the other one. Okay, so we go back to the type is, now the type is 3. And you know what I just did? I just did one of the diodes. I didn't even do the triode. Let me do the other diode, then I'll do the triode last. Okay. Back to type 1, 12.6 filament, 35. Plate, top, just reset these in the middle. Top is F, bottom is B and C. And start it up. Set the line voltage to the middle. Let the tube heat up. Okay, we're getting a glow there. And okay, so I just tested one of the 2 diodes. I'm about to test the other of the 2 diodes. So check the tube for shorts by moving the levers shown in light type. Light type is F and B. So F, B. Nope, looks good. Check for quality. Now look at that. That one's actually good. Let me reset the line voltage. So watch this, and you see the meter there. This one actually moves into the good range. So one of those 2 internal diodes kind of read on the margins of being bad. This one's actually reading on the margins of being good. Okay. I don't even know if those diodes are being used in this circuit. I don't have a schematic, but I'm more interested in hoping that the triode portion, which I haven't checked yet, is actually good. Okay, testing for open elements. Hold the test down, move each lever on the top position to the bottom. Satisfactory by change in meter reading. Yep, there's a change in meter reading. That's good. And I don't need to do the filament test again. Again, I've already done that. Okay, now let me turn this off and reset this to test the diode, or the triode portion. So for the triode portion, it's type 3. 12.6 for the filament. Plate is 26. So we're going to reduce that to 26. Top. Reset these. Top is A and G. Bottom is B and C. Turn it on, and let's let the tube get heated up. And let's start again. Okay, now for the triode. Hope this works. Okay, shorts. Light type. Move them through the positions. Light type is A, G, and B. No shorts. Quality test. Meter moved down to the right on the border of being bad. Right there. So the triode is, well, you know what, the line voltage needs to be, okay, hold on, I gotta reset the line voltage. Try that again. Alright. So we can see that the meter is still in the yellow. So it's yellow is between good and bad, means it works, that's fine. Triode is working. And let's check for opens. Okay, while holding the test, move each lever that's in the top down to the bottom, and satisfactory elements are going to glow. No, change of meter reading. Okay, so top, there's a change, good. Top, not much of a change in that one. Move each lever in the top position. Oh, only those in light type. Okay, well, G is light type. Okay, there's a slight change. Yeah, there's a change, so that's good. And one more time, check the filament. The same filament for all of them though, but set to 0.75 volts. Move each lever shown in dark type. In this case, it's only C, and you get a glow. And yeah, it's glowing, so it's good. So power off. The 12AT triode is good. Let's go, I'm going to hit pause here and then look up this, it's a 50C5. Okay, fortunately I do have the 50C5 on the tube tester here, so type is 3, filament is 50, plate is 17, (10, 12, 14, 16, 17). Okay. Top is B, E, F, G. E, F, G. Bottom is AC. Okay, let's start it up. Hopefully we'll get a glow out of this. Yes, the filament is glowing. We'll let that warm up. Set the line voltage, which is looking good. Okay. We're going to check for shorts. Moving levers in light type through the two positions. Look for a glow. Light type is F, G, and A. Okay, no shorts. Check for quality. And that is showing down in the slightly into the bad range. Again, these are old tubes. So you can see the meter is moving downward. Oh, again, right on the border between questionable and bad. That's good enough for me. It works. Test for opens by each lever in the top position while holding the test down. Change of meter reading, good. Change, good. Change, good. Change, good. And we're going to check the filament by going down to 0.75. And the levers in dark are B, E, and C. There's a glow, good. E, glow, good. C, glow, good. Tube works. Let's move over to the final tube. Okay, the final tube is a 35W4. I'm running out of batteries on my camcorder, so this might die at any time. 35W4 is on here. Type is 3. Filament is 32. Plate is 20. And top is E. Bottom is D, F, and G. B, G. Let's turn it on. Look for the glow. It's glowing. Let it warm up. Okay, check for shorts, levers, and light type. E, no light, good. G, no light, good. Do the test. Oh, look at that, that's good. If you can, I don't know if you can see that, but yeah, you can. Testing the tube, this is actually moving up into the green good range. So this tube tests the strongest out of the three that I have. And that's good because this is our power output tube anyway, so glad to see that. Okay, we're going to test for opens by holding the slide switch in each lever in the top position, only those in light type. Okay. E. This time we want a change in meter reading, that's good. And light type top, that's it. Just E. And then do the filament by going down to 0.75, and each lever shown in dark should get a glow. Dark is going to be, ouch, had some kind of a metal fragment there. I think I got a metal splinter, crap. Ow. Dark is D and F. There's our glow. There's a glow, good. Okay, well this tube, all the tubes test out well. I'm really happy about that. That is a good thing. So we are finished testing these tubes. Very, very happy that I don't have to find replacement tubes for this, because I'm, like I say, this is a cheap little Portland amp and I want to just get them running with minimal expense. Okay, now what? Well, I don't know what. I think maybe it's, well, I still have a battery left in my camcorder. Maybe it's time to hook this up to the Variac. Let's first put the tubes back in, and I'm going to leave the cover off. Okay, here's our 12. There's our 50 C5. And our 35 W4. I'm a little worried about this because, like I said, somebody's done some work to this thing and bypassed this old electrolytic. But let's go ahead and hook this up to a load here. Got my my ugly 8-ohm wire wound resistors. I need to come up with a better dummy load than this, but that's what I have for now. Okay. I'm just gonna put a little electrical tape on one of these so they don't touch each other and short out. Alright. So we have our load, 8 ohm wire wound dummy load. Gonna zoom out. Go ahead and take the, again, I don't see any problems visually, so let's say a prayer here. Let's go ahead and take the power cord and turn on the Variac and adjust it down to 0. Okay, turn it off. Plug it in. On. And I will turn off this light here, turn this Variac off, and there's a power switch. There it is. Okay, I'm going to start out with the power switch on and the volume all the way down, and I'm going to turn it this way so we can see the tubes glowing, hopefully. And I don't see any shorts. Okay, power's on. Okay, I'm going to bring up the voltage slowly. Okay, we are now at 50 volts. And I don't know if you can see that, but I'm now starting to see. I shouldn't be probing around with a metal screwdriver. Isn't that stupid? We're now starting to see the pilot lamp glowing. And I'm going to go ahead and take it up to 110. We're now at 110. And the pilot lamp is glowing. And the you can see the tube filaments are glowing. I'm looking for something. There we go. It's a pencil. It's a better pointer. Okay, I'm now going to keep one hand behind my back. And in my pocket here, I only point with one hand. So the pilot light is glowing strong over here. Let me take this off the tripod because batteries are about to die. So, all right. So this is the first time this amp has probably been on in a long time. I don't have a signal input to it at all. I just want to make sure everything's glowing. And there's the pilot right there. And each of the filaments is glowing strong. I didn't hear any snap, crackle, pop. So we're off to a good start. Doesn't mean it works. I mean, it doesn't mean it's going to do anything with the signal. We're going to figure that out next. You know, yeah, I think I want to cut it short right now and end the video, and then when I pick up next time, we'll put an audio signal through it, hook a speaker up, and just listen. For now, I'm just going to let this burn in for a little while, for a few minutes, as the components heat up, just see if anything fries. If so far so good. Get a flashlight here. Where's my light? Kind of violating some safety by having both hands out right here, but I'll risk it. We can see all the old components in here. Those are old carbon. Turn the light on here. Okay. These are the old carbon type resistors, which are the worst. These old carbon resistors change. I need to do a video on that. They change resistance dramatically based on changes of temperature, and that causes it's almost like, you know, what an active device does. It causes a major distortion. But you know, these were what were used. Nowadays you use a metal film. Much better. And these are the old ceramic capacitors. That is an electrolytic that needs to be replaced. Of course, that's an electrolytic that needs to be replaced. We looked at that, so I think that's been bypassed by this one. And there's our output transformer, and there's a big, it's hard to see, there's a big old, let me turn the power off this thing. Still not going to mess with it too much because I haven't discharged the electrolytics, but down there's a big old carbon power resistor, I guess. Kind of neat looking. When I get this cap out, that'll expose that a little more, and we'll take a look at it, measure it. It says Chicago, the something company. It's a big, like, slab of carbon with an input and an output. It's got a metal casing surrounding it, and I'm guessing that's a power resistor. It's kind of neat looking. I'm not sure what that is. I'll have to take a look at that when we open it up. But anyway, it's kind of cool the bulb still works too after all this time. And it appears to be a simple circuit. That's a wire wound resistor right there, I think. And that's it's a real simple circuit. So in the next video, we'll go ahead and put a signal through it, audio signal, and give it a listen and see what kind of buzz and hum we have. I'm still going to, regardless if it sounds good or not, I'm still going to replace the electrolytic, because I happen to have one it's not exact, but it's good enough. Let me pop that. Okay, yuck. It's got this waxy stuff. It's just falling apart. But we can see that we have red. These are microfarads. So red is a 40. The other red's a 40. Blue is a 20. And they're 150. 150 volts. Black is the common negative. So they're all 150 volts, I'm hoping. So 40, 40, and a 20, all in one can, so to speak. And what do I have? What do I have? These are actually really good electrolytics. I've got, it's got 4 of them in one can. This is a 40, a 40, a 20, a 20. So it's got one extra 20, and these are 525 volts, so no problem with the voltage. It's bigger, so this will never fit inside the case like the original, but I can have it outside. I'll have it outside somewhere. Okay. Alright, I think my battery's about to die, so that's enough for now, and next time we'll put a signal through here and give it a listen, and then we'll start the restoration process by changing out the caps, and hopefully from there it works and sounds good, and I'm also going to start working on that speaker. Cheers.